over and over again. Okay, the very first thing when we covered logarithms is that it is something to help us go about solving an equation sometimes, especially when the bases are different and we want to find an unknown x. So the first thing that we wanted to know is how do we change from index form to logarithm form. Okay, for which the base a itself will be the base for the logarithm, small number at the bottom right corner, and then followed by y over here, the subject, and then the power on the other side of the equation for logarithm. Then we covered very important concepts yesterday about log a base a being equals to 1, log 1 base a equals to 0. So these are some special values. But because we have already learned how to do change of bases, okay, we are able to know this very easily if we are familiar with changing bases. So maybe let's touch on changing bases first. Say for example, I have log b base a, okay, and I want to change it into a base of c. That will mean that, okay, the original b that we have over here will be on the numerator, while the a that was in this original base will be in the denominator with a new base of c. Okay, so that was what we learned about changing bases. Just change the c's. Okay, and that is very helpful because in our calculator itself, our calculator only has our common log with the log button, and then also the natural log, the log button. It doesn't matter we are using base of 10 or base of e, okay, when we want to use the calculator, because yesterday we learned that it gives the same result eventually as well. Okay. Then we have covered 3 very important laws. Okay, we have our power law, log x to the power of r, the base of a. Okay, what will happen? What is equivalence to this log x to the power of r base of a? What can we do? Farid, what do you think? What do you think?
Bring the r to the right.
Bring the r down, right? So that was what we did yesterday, right? And then we have our product law. Okay, when it is a product within one logarithm, okay, we can separate it out into 2 logarithms of the same base. So since it is a base of a, okay, how do we go about separating it out? What do you think? Renee, what do you think? This is an x, then operation plus, okay, followed by y. Okay, so the product actually becomes a plus now. Then when it is a quotient, when we have x over y, okay, in one single logarithm, likewise we can also separate it out into 2 logarithms, okay, with the same base of a, right? And what we have over here? Yes. Okay, so it becomes a minus. Right, so these are the laws that we need to be familiar with. Okay. Yesterday, I ended off at, hang on, try 19 part A. So I want to finish up try 19 part B. Before going into learning how to solve equations. Okay. We have here log 200 base 5 minus log 64 base 25, and we want to show that it is equals to log 25 base 5. Okay, so yesterday when it comes to presentation, I have showed that we will start off by from the left hand side. In case you are wondering, why is it that we must start from left hand side? Can we start from right hand side? The answer is yes. Okay, it is possible to start from right hand side and show towards the left hand side because it is equal. Okay, so left hand to right hand or right hand to left hand, it doesn't matter. But the reason why I start off with left hand side is because it is much easier to simplify difficult things rather than to make easy things difficult. You agree that is also a principle in life? Okay, difficult things you can make it easy, but easy things you want to make it difficult for, okay, that is a challenge now. Although sometimes I mark your homework make easy things difficult, okay, which also is a surprise. Alright, yes, okay, cool. Alright, so making difficult things easy is usually much easier. Right? So from here, log 200 base 5 minus log 64 base 25. Since we are trying to gear towards base of 5, right? Okay. The first thing that we want to do is to consider changing this into a base of 5 first. Right? Okay. So by changing base, we get log 64 base 5 divided by log 25 base 5. Okay. Then what next? What will you do next? Cancel. Let's select someone. Eqns, what do you think? What will you do next? Definitely we have to apply some laws. Easy part of the question that we're at now. Okay? 25, if I change it to a base of 5, what is it? 25 5 square, right? Okay, we can tackle the easiest part first. Okay, when you have 25 expressed as 5 square, you can bring the 2 down. For which we have log 5 base 5. Okay, and that is 1. Right? So denominator of the fraction is now 2. Okay? Okay, then what next? Can we do something similar to our log 64 base 5 and maybe log 200 base 5? What can we do? Any suggestions from anyone? Ideas? 64 is base square, right? And then 100 is what? It's a 200. What can I break 200 into? What are these factors? 2 and 100, yes. Okay, but let's just break that down further. Not wrong. 4 and 25. Is it? 4 and 25? 8 and 25, right? Okay. So we break it down into 200 into 8 and 25. Okay? There's nothing wrong with 2 and 100, just that it's not very helpful. Okay? 8 and 25 is helpful because we know 8 is actually 2 cubed. And 25 is 5 squared. Right? Okay? Then, now let's simplify this one first. I'll just keep that 2 cubed and 5 squared here. So I bring the power down. Okay? In fact, if you want to, anybody think of 8 squared changing into 2 to the power of 6? 8 squared, okay, now we keep to this, okay. Then this will become division of 2. Okay, like that, right? This case is a product, right? use our product rule, become addition. Okay, your 8 is actually 2 cubed. So do you notice that this and this subtracts out? Okay, log 2 cubed base 5 minus log 2 cubed base 5. It is a zero pair. So you'll be left with log 5 square base 5. 5 square is another 25. And that is the right hand side. Okay. Can the solution be shorter? Definitely yes. Okay. Because what I've done here is I did things individually one at a time. I do not want to hurry you. Okay. So don't try to pressure yourself to seek to write the shortest answer. Okay, try to pressure yourself to instead give the most accurate answer first before learning how to get the shortest answer. Okay. Any questions? Yes.
How do you get log 64 base 5 over log?
How did I get this now? Oh, because I'm changing bases here. This is a base of 25, I'll change to the base of 5. Okay? So in our change of base formula here, the big number is in the numerator, base is in the denominator. Yeah. So 64 in the numerator, 25 in the denominator. With a new base of 5. I just did change of base.
But how do you know which base to change?
Because I observed that I eventually want base of 5. My goal is this one, my right hand side. This is my goal. Now here base 5, now here base 25. I should work towards my goal, right? That's why I choose a base of 5. You understand? Okay. You sure? What are you not sure about? Why base 5?
So you can just change the base.
Yeah, if I change the base, they're equivalent, they're equal. I can change to a base of 3, base of 7, base of 10, base of 1 million also can. Yeah. But you should work towards the answer. Okay? You decide the base that you want to change. The strategy is to work towards the answer. Right? Okay. Any other questions? Moses, you had a question just now?
I'm sorry.
Okay, great. Okay, be clear? Right, that's why there's a need for so much more questions, okay? For you to practice. Alright, if you're good, then let's go into chapter 5.4 on logarithmic equations. Okay, remember our reason why we actually, the motivation for us to learn logarithms was to learn how to solve equations such as maybe 2 to the power of x equals to 72. Right, for which we know 72 cannot be expressed into a base of 2. Okay, how will I be able to know what is the value of x? Right, so this was our motivation for us to actually learn how to learn your logarithms itself. Okay, for which we're going to touch on that in logarithmic equations, and we still need to know all of this over here in order to solve a logarithmic equation. So I'll erase this first. Okay, start by looking at try 20, where we want to solve these. Okay, let's start with part A. So we're not yet trying to deal with such things, We're just trying to learn how to solve an equation with logarithms inside it first. Okay? So we want to find x. Okay, keep in mind that log is not algebra. It is not about multiplying things. You cannot just bring it over to the other side. It is a function. Okay, so in part A, if our objective is to find out the value of x, I need to go in reverse. I need something that helps me to reverse the logarithm. And remember, how we get logarithm? It came from indices. Okay, so actually the reverse is to go back into our index form. So from here, okay, going into index form, it will mean that base of 2 power of negative 1 equals to x. Therefore, your x is just half. Because 2 to the power of negative 1 is 1 over 2. Your indices terms. Okay? Then your part B. Okay? Notice that in all three question parts, our x, our unknown, is in different locations of the equation. Over here, your x is here with the logarithm. Part B is on the other side of the equation. So how do we find the value of x? Okay, this one's simple. Because you already know how to press calculator, right? Okay, you could. One option is to press your calculator directly. How do you do that? Change it into a base of 10. Okay, I'm just writing this for us to know how to key into a calculator. Otherwise, you need not write down log 81 over log 3. You just have to press your calculator and you tell me what's the answer. What do you get? 4. Okay? The log button is just the LOG button. Fair enough. Okay? I changed to a base 10 because the calculator can only do base 10. Okay? Common log.
Why do you want to do that?
Because your calculator can only give base 10. Your calculator cannot write log 81 base 3. So that's why I want you to press the calculator. Okay? Okay? All of us can press calculator. Right? Don't take things for granted and then later on in exam you cannot press on. Then I cannot help you. Okay, because I still remember last year, Set 3 end of year exam, this one student raised her hand, asked me how to press the calculator. I tell her, I cannot help you. Okay, so you have to learn it yourself, all the calculator functions. Okay. Alternatively, okay, another method, which actually a little bit unnecessary, but I still want to cover it. Okay, of course, in this case, you can change it into your index form. It will be 3 to the power of x equals to 81. Coincidentally, 81 can be expressed in the base of 3. That will actually be 3 to the power of 4. Okay, and therefore your x, by comparing powers, is equal to 4. That's an alternative method. Okay, but since we already know our calculator method, you need not be that familiar with this. Okay, next part C. If we have log 16 minus x base x equals 2, we want to find out what is the value of x. So, similar to what we have done in part A, we have no choice. Okay, because we cannot press calculator for this. We have to change it into index form. Base is x, power is 2, x squared equals to 16 minus x. Yeah, it's not 16. Oh, 6. Sorry, thank you. I've misread. Okay, so this shouldn't be difficult to solve, right? This is a one-count equation. Quadratic. Okay, so you just have to bring everything to one side. Use your quadratic formula or factorize. In this case, you can factorize. And we get x equals to negative 3 or x equals to 2. Are we contented with this answer? No, why not? Because, okay, remember our definition of logarithm is said that your y and your a over here must be positive. So look at where the unknown is. Your x is actually here, and then you also have x over here. With x being the subject, being the base over here, it cannot be negative. So we got to reject this, and the reason, okay. Because your unknown is the base of the law. Okay? So always remember to check the validity of your solutions. That is often overlooked. Okay, let's dive deeper. Okay, where we have this. Okay, we first look at part A. Yeah. No, unless the question asks you to explain. Okay? Yeah. You see? So let's start with part A. Okay. For part A, right? How would you start your solving process? Any ideas? We're trying to solve, not to prove. Okay? So we're not trying to show anything. Please make sure it's solving. Yes, Eden. Bring everything to one side. Okay, sure. I am open to that. Nothing wrong, right? Okay, maybe I want to just ask, what if we open the brackets? Like I mentioned many times, logarithm is a function, it is not algebra, so you cannot sort of expand. You cannot say it's not right, okay? Say log x base 3 plus log 3 base 3. That's not correct. I got two spectacles. Okay, so you cannot expand, not right, okay? Right, so this is algebraically not correct, okay? Or rather conceptually not correct, right? So maybe Hayden, you want to explain why you move everything to one side first. What do you intend to do? Put everything together into a single log.
Oh, it's because the...
What? So put everything into one single logarithm. Okay, so that is what Hayden is proposing. Put everything into a single logarithm. Okay, I'll continue here. So your x plus 3 over x. able to solve the equation like that already. Manageable, right? Okay, so can cross multiply lah. So x times x minus 1 equals to x plus 3. Okay, like that. But I want to say I wouldn't have approached the question in the same manner as what Eden has done. Okay. I wouldn't have brought all the logarithms to one side. It's not necessary, isn't it? Okay, so what do I need? Okay, actually, I erase this, what I would have done is that I just combine these two. Okay, into this manner. So a fact about logarithms is that, okay, while it's not right to think about it as cancellation, but because the bases are the same, okay, for both logarithms on both sides of the equation, naturally your x plus 3 must be equals to x times x minus 1. Okay, it must be that way, yes. Okay, so that is the equivalence of logarithm. Just like how we do comparing of powers, okay, equating of powers in indices, we are also equating the subjects over here in your logarithm. Okay, so I can say x plus 3 equals x times x minus 1. So actually I need not go through this lengthy process. Okay, so that's a much shorter method because from here immediately you go into solving something familiar already, right? You also arrive at the same equation. Okay? Right? Yes. Yes, that's what I'm teaching you. Okay. So I would expect you to be aware that once I have a single logarithm, must be one single logarithm on both sides, you can say that these things in brackets over here, they are equal. Okay? Provided that the base is equal. Right? So in this particular question, it also asks you to explain why one of the answers is rejected. I think we are aware that x equals to negative 1 needs to be rejected because earlier on we already said that your base must be more than 0. So how to go about explaining it? Okay, you can say that x equals to negative 1 is rejected because log 3x will not be defined. Okay, so we just have to say this. You don't have to tackle all the logarithms because your x appears everywhere. You don't have to pick all to go and talk about it. You just have to pick one of them. Okay, because in this case, right, this subject over here cannot be negative also because y is positive. Okay, so therefore this is to be defined. Hence, your x equals to negative 1 is to be rejected. Okay. Yep. Yep. Can you ask Vivian to help you? Vivian, can you help model please? Or Yongler can help. Yongler, you got one request here. Maybe next time we need a big bag. You trolley. Yongler, you just bring the water cooler here.
Why so many?
want to solve in course rejection because of the way things are like here. Okay, for example, if I change the question such that it is x minus 7. Okay, so if your answer ends up to be x equals to 3, 3 minus 7 will be negative 4. Then the logarithm will not be defined anymore. Okay, so don't take for granted that positive answers will always be okay. Right, so it is important to go and check. So, okay, now we go into part B. Okay, we want to solve this. Okay, how? What will you do for part B? Any ideas? Yourself, you seem hard at work. Will you share what are you working on? Yourself? Okay, tell us how to start this question. How to start this question? So the 2 change to... Oh, okay, you want to write it like that? Like that, huh? Okay, then you say like that. Okay, then the left hand side left. Combine. Okay, so we can combine to a single logarithm. It will be 4 times 3 minus y. Okay. Then after that, we can say that this 4 times 3 minus y is equal to y squared. Nothing wrong with that. Okay. But I just thought, set alternative. Do we really need the log y base y? No, right? Why? Okay, so from here, I still need to do the combining. Okay. Even if I don't introduce the log y base y, I can change it into index log, right? Y squared equals to 4 times 3 minus 1. You do get the same thing. Okay. So I want us to be very flexible in terms of the way we do and solve the question. Okay. And be very skillful at it as well. Right? So regardless the case, we end up getting a quadratic equation. I'll just continue from here. So we get y equals to negative 6 or y equals to 2. Okay? So for y equals to negative 6, we got to reject it because y is in the unknown. Okay? So how can I get y squared?
understand the y1 from there.
Yes.
How do you get y square?
How do I get y square here? Because changing from logarithm form into index form, base power. Y square is 1.
Then where did the 2 go?
Then 2 is here, square lor. Okay, any questions? Okay, Lola, this will be needs your help. Thank you. Okay, do you all like to practice? Okay. I think otherwise Isaiah is going to just collapse from his stroke. Sitting up. Okay, you want to do something easier? Or do something different from what you're doing?
Easy.
Okay, I give you all mix up, okay? Size 5.4, page 124. Yeah, 5.4 already. Okay, so this one.
I don't know.
You want to do something
Yeah, I
different?
don't know how to do it. Just for Malay lah. Mas sini lah, tahu ni dulu. I don't know. Tidak tahu.
Okay,
What is this?
let's do this. Okay, I'm not sure whether do I need to go through 8B or not. Okay, but just to check, moving on from here, you should be able to get a quadratic equation. I'll erase the question here first, huh?
I still
Okay, moving on from here, I'll just take some steps as well. Okay. You won't be able to get x squared minus 2x minus 24. Okay, so I hope in question 8B you're able to get x equals to 6 or x equals to negative 4. Are we able to get that? Yes? Okay, great. So we need to reject an answer, right? Okay, so we reject negative 4. Why? Okay. So it is not as clear as what we saw previously in other questions. Okay, because our unknown is not in the base itself. Okay, so you may need to test it out. The easiest one to test is this one, okay? Because this one looks a little bit complicated. So while the question did not ask for an explanation, I just want us to practice it. So when x equals to negative 4, we have this, okay, from the question to become log negative 9 base 2, okay, and it is not defined, yes, squared. Yes, okay, so this is not defined. Okay, so that will be how we explain it as well. Okay. Then for solve x equals to negative 1/4. X equals to negative 1/4. And get, okay? And then, looking at question 22a, any questions regarding the way we solve? Okay, now the way I approach the question in 22a may not be the same way as what some of you may have done. Okay, I also decided to be very clear in my working. That's why I did not skip any steps here. But I am aware that some of you are faster in thinking, already and very familiar that log a base a is 1. So you know that 2 ones I bring down, this will actually be 1, and just skip from this step to this step. That's perfectly fine. Okay, so nothing wrong at all. It's just that I know some of you are still not yet familiar. That's why I wrote down the steps very clearly here. Okay, I am also aware that for some of us, you ended up at this step and then you decide to cross multiply already. Okay, with here, where you bring the 2 over to the other side. That's also fine. You will also get the same quadratic equation. So not a problem at all. Okay, so your solution in the end will be x equals to 3 or x equals to negative 2. Okay, so I'm skipping all the steps in the solving part. So we have to reject x equals to negative 2 because otherwise this will not be fine. Okay. Now I want us to look at part B to just wrap up for the day. Okay. Now in part B, right? What some of you decided to do is when to proceed to calculate what is 3 to the power 6, which isn't very helpful. Okay? Because observe that the base is 3, so it's actually quite helpful to keep it to a base of 3 for this index form over here. So what you could do is to change to a base of 3 for the logarithm on the right side and arrive at this. Because once you get this, for this log 3 to the power 6 base 3, I can simplify it into just 6 itself. Because log 3 base 3 is 1. Okay? Therefore, most majority of you may get stuck over here already. Okay, which is why I gave you a hint just now, which is do by substitution. Why you get stuck? Maybe you still went on to proceed another step, which is to multiply across with log x base 3. But still, it is not helpful because there's no way for us to simplify this. Okay, I want us to be clear that this with brackets around the logarithm and the square, it is not equal to the one without a bracket. Okay? This and this, they are not equal. So the way to get around it is to do by substitution. And what I mean by substitution is to let u to be equals to log x base 3. Okay? So we will have u squared minus 6 equals to u. Okay? Questions at this juncture? But not forgetting that we are not trying to find out the value of u. We're trying to find the value of x. So don't forget that often gets missed out. So we have log x base 3 equals to 3 or log x base 3 equals to negative 2. Then we solve it individually. We get x to be equals to 27 for the first one, and the other one, 3 to the power negative 2 equals to x. So x is equals to 1 over Okay, I will call it a day over here. Okay. Next lesson, then we will tackle on those indices equations. Okay, as well as going into the graph part. Okay. Remember tomorrow there will be a Eqns test.